Hello, everybody. Welcome once again to this amazing episode. And it's day 9 of our 25-day VLOGMAS series that's looking at Python tidbits. And from day 8, we ended up with our own self-defined function and then passing that using the map function on a defined list of, let's say, data, and then it sort of iterates through and then runs the function on each element of the data set. In this episode, we'll be looking at how to just have a combination of the Lambda and then the map function. All right, so what we want to do is to reduce our line of code for this function, the self-defined function. That's the one highlighted. And so we would want to use the Lambda function in that case. So what we can do is, before our inputs, to define our Lambda. Okay, so let's have the keyword experiment or our function name experiment to be equated to our Lambda function. And then our input arguments are X and Y. So we have Lambda, then X, comma Y, then we place a colon. And then the first output is the if part. It should return X plus Y. So we return X plus Y if X is greater than Y. Else, there should be another condition. But then because we also have another if construct, that's the elif before the else, we open another parenthesis and start another if statement for the second part of the elif. So which should be the output, which is in this case, y minus x if the condition y is greater than x, else we print out x to the power y. And this is enough to replace the whole function we've written up there. This is just a one-liner using the Lambda function. So we can take off this whole part. And then our code structure has been reduced. Okay, so with this, all we are doing is to regenerate a new list using the map where the function, which we are calling the function name experiment. So we are calling this function experiment on our inputs of X and Y, which is the A and B in this case. So if we run this, we should have C, and C would be the outputs based on A, B, and then C. So for instance, let's look at the final output of A. This is what we have, the final output of B. This is it. Then the final output of C. So from here, we notice that A is lesser than our B. So A being lesser than B means that X is lesser than Y. So that's the Y greater than X part. That means we should be left with the action Y minus X performed. So we are going to have our B1, our B -1 minus A -1, and that leaves us with our C. So we try, and then we get the same output. So that means that part of the function was executed. And that's how you simply bring together the Lambda and then also the map function. Well, somebody else would, if you don't want to, replicate the script, then in place of the experiment, it means we can just cut this and then place it all in this part that's under the function component. And then you'd have a really defined, like a definite one-liner just for the function and then the map. Okay, the Lambda and then the map function. Okay, but then because we would want to replicate this function, so it's best to then also have the Lambda redefined to a particular variable, and then you just call the variable as the function name in the map. So there are multiple ways of doing it. Now let's look at another function and see how to regenerate that. So we have something as this. So what we did in here was to create a grading system, okay, which is just a sample project. So just creating a grading system based on an individual score. So when we pick the individual score, we see what range it falls within, and then we produce out the individual score and then also the grade, and we pass it to an output. So based on what condition or what criteria is met, it is returned that value, and then also the grade is returned. And what we did was to generate a set of random marks for 300 people. And then in the end, because we wanted the mark to be a total of 100, what we did was to weight all of them by the maximum A, that's the highest mark in the A that was generated. We divided every A mark or A score by the maximum, and then multiplied by 100 to scale everything back to 100%. Then in the final part, what I did was to map the grade function to the scores that we have saved in A. And so it generates a list of the individual scores and then their respective grades. So if you run this, and then we type in our final variable of class, we have a set of grades with their, a set of scores with their grades. So for instance, somebody with 34.41 definitely is an F because it satisfies the criteria, which is the else, okay, because it's definitely lesser than 40. So it goes into the else part. Somebody with 72 definitely has an A because A is greater than 70. Okay, so this is in a whole sort of block. We can also reduce this back to just simple lines. So what we will be doing here in this case is, let me increase the font size a bit. So what we'll be doing here is to rather pass the variable named grade and equate it to a lambda function, okay? And lambda now, depending on just x, which is an input, just one input. We have our colon, and then the first thing to print out is the x and then the a, provided the condition is greater than 70. So we're going to print out x and then the string a. If, bear in mind, these are multiples, so I had to put them in a bracket. So if the x value is greater or equal to 70, then there's the else part, which is for all other conditions. But because there's a set of elifs, it means we can create another if within the else part by opening a new bracket. And that is to echo out this output, which is, in this case, x, that's the individual square, and then rather a b if the x value is greater than or equal to 60. Okay, and then aside that, if there's an else part, so what we are doing is, let me put it this way, let me bring this out. We have the else part, but then for the else part, we also have another criteria. If this is right, else, okay, we open a new parenthesis. Okay, so let's write it in this form, and when we are done, we'll pass it back from the lower into the bigger brackets to make it easier. Okay, and then we also have this third component, which is to print the same x and then a c if the person scores greater or equal to 50, else that's the remaining, every other part. And then the other aspect is for d, if the student scores 40 or above, which is this part of the function. And then the final aspect is just to print an F for anything less than 40. Okay, so rather than putting this as a new block, that will be the final else statement. So we don't even need to pass that. We don't need to create a new definition or a new lambda definition for it. And all we are going to do is to replace this else with that. That's the final part. So it means D, when the criteria is greater or equal to 40, else it should print X and then F. Then we are, this is another elif part, which comes in the if component of the one above. So we are going to cut this whole part and place it in the parentheses for the else above. And then we pick this whole line, line 37, and then pass it into the parentheses of the 36. And then when we are done, we pick the whole of line 36 and pass that as the else component of the main line, that's line 34, which is our grade. And so once we are done, we can delete this function out. And that's how we get our function written. Okay, so now we are maintaining the same A. We generate random numbers using np.random.rand and 300 random numbers, and we scale them by the maximum A times 100 so that we can have a maximum of 100 and then a list of say 0. And then this is the component that makes use of the Lambda function. The Lambda has been, well, let's change this new name. Let's say, let's call this score. Okay, so now our function name in this case will be score. So we are going to map the function name score against our data or our list, which is the A in this case. And then from there, we generate a list. So if we run this, it should give us an output as we saw earlier for a new set of random numbers. And so somebody with 83 and above, A, 74, A, 2.5 is an F, 91, A, 35, F. And we just reduced, let's say, about 10 lines of code into just 4 lines. And it can even get better than this. And that's how useful the mapping and then the Lambda combination could be. It can be useful for refactoring a whole iteration. Okay, I believe you enjoyed this session. If you have a comment, you can leave it in the comment section. If you have a question, you can also place it there, and then the team would respond to your questions. If you are new over here, don't forget to subscribe, to like, and then to share. And we hope to see you on another video. And like we always say, it's always bigger and brighter up there. So make sure you push yourself, explore, and get better with the Python language. And it's always good to have you also at the top. It's always huge to accommodate all of us. Let's keep learning. Let's get getting better. Have an amazing day. Bye-bye.